So, we now slowly get into the closure of this course, and this is the last segment of the course. We have done or covered a lot of topics in steel making, starting with an overview of steel making, the science based fundamentals, description of primary and secondary steel making processes, casting processes, modeling. So, you have now a fairly good idea of the subject of steel making, and with lot of supplemental problems which you can concurrently solve with this course or the course material as the background material, course content as the background material, you should be equipped to handle many challenging problems on the shop floor as well as from the viewpoints of design and process analysis. Now, having said so much about the subject of steel making, perhaps the concluding lecture must give you, I would not say lecture, but maybe lectures must give you some information regarding the state of iron and steel making in India. It is for us now to review that how the subject or the industry has grown in this country, what future stores for us, and what are our problems, how can you address. And I think the teaching of the subject is not going to be complete unless really we give you some background in the history of modern day iron and steel making in India. And you must remember that since independence, this is the first or the foremost heavy industrial sector, and today we are an extremely proud nation as far as steel making is concerned, producing nearly about 55 million tons in the year of 2009 through primary and secondary processing routes. So, many terminologies that I am going to use here, you are already accustomed, you already know those terminologies. So, it will be easier for you to grasp when I say that secondary steel producer, electric furnace steel producer. So, you know that I am referring to many steel plants or many steel sectors which basically uses electric arc furnace and continuous casting today. Now, the history of iron and steel making in this country is extremely old. I think there is indication that it goes back as far as the third millennia. Now, most of you have seen or heard about the iron pillar. We have a very rich history of iron and steel making. I mean, you go to the Mohenjo-daro civilization, even it is documented that when Alexander the Great came to India, his soldiers needed to reinforce their arrowheads, and it is the Indian, localized steel makers. They helped, Alexander and his troop, and provided them with the necessary armaments. So, we are not interested in that history. There are many excellent resource material available on the subject of the history of iron and steel in this country. Professor Ranganathan of IISc Bangalore has written textbooks with Sharda Srinivasan, and there are compilations by the Ministry of Steel as well as the Joint Planning Committee which traces. Tata Steel also has some compilations, and if you come across this which are there in archives today, you should get a fairly good idea of iron and steel making, in the prehistoric time, 1000, 2000, 3000 years back and so on. Now, coming back to the modern India, I mean referring from the dates in the times of the British Raj, I would say that the first notable attempt was actually done on a large scale production of iron, particularly pig iron, by a foreign national who tried to do it on a very small scale basis, about 40 tons a week. That is the rate of pig iron production somewhere down the coast of South, and his name was Joshua Heth, but somehow the quality of steel pig iron produced was so inferior that with the competitions that were there in the market, the fellow could not compete, and soon his facility were shut down. So, this happened somewhere around 1830 along the coast of Madras. Now, after that, around 1874 or so, this Bengal Iron Works, it started functioning. Bengal Iron Works. So that's about 1874, and where it started near the vicinity of Asansol, Kulti, Burnpur area. But soon the iron company faced some problem, and it was taken over in 1889, I think. Yes, in 1889 by the Bengal Iron and Steel Company, and it was still called BIW, but this time the Borakar Iron Works. Ultimately, so this takeover, the closure of the Bengal Iron Works and the formation of the Borakar Iron Works, or renaming of the Bengal Iron Works as the Borakar Iron Works. This is Borakar Iron Works, and this is Bengal Iron Works. So this was under the aegis of the Bengal Iron and Steel Company, and then ultimately in that locality, somewhere around 1937 or so, the ISCO Burnpur factory also came. So how much of iron was produced? Somewhere around 40,000. That was the rated capacity, 40,000 tons. This is 1,000 kg metric tons of iron. So that was around the beginning of the 19th century, and then the end of the 19th century, and then the red letter day in the history of iron and steel making came, and which is August 27th, 2007, when TISCO was launched at Jamshedpur. Of course, at that time, Jamshedpur was known as Sakchi, and Jen Tata started, Jamshedji Nauroji Tata started the TISCO factory with a rated capacity of 120,000. Iron and steel, so it's a finished steel production, and the first product rolled out sometimes around December 2008. That's the time when TISCO produced the first steel, and in the beginning of, this is 1907 actually, I'm sorry, yes, so this is 1908. So TISCO actually recently celebrated their centenary, if most of you are aware of this. So around 1917, 1923, 1907, around that, we had three different sectors where iron and steel was produced: TISCO, and then 1917, that is the ISCO, and this is the Bhadravati Iron and Steel Company in South India. So that was the scenario in the post-independence, about 40 years before the independence, and these were the three companies which were mostly rolling out steel. So actually the Howrah Bridge, the old Howrah Bridge, now over the Ganges near Calcutta, we have several bridges, but the oldest one, which connects actually the Calcutta city, which is a cantilever bridge actually. So it's a suspension bridge on both the ends. There's no pillar at all in between, and that the steel for that bridge actually. So it is a symbol of national pride actually, that long time back, around 1930s or so, we could produce steel, and this Howrah Bridge today stands at long 80 years, and we must be very proud of our extremely old heritage. Now, following independence, the steel sector started to grow, because Nehruji really envisioned, that we have to develop, and a developing society without steel perhaps cannot sustain. I mean, you see everywhere. I have mentioned also that the consumption of steel is an index of the prosperity of the society. Consumption of flat products is really an index of the welfare of the society, how good the people are living, what are their gross income and so on. These are indication. The standard of living, steel consumption, standard of living, flat product consumption, standard of living, these are all synonymous terms. So, after independence, the steel production sector grew remarkably. So, somewhere around 1920 or so, when we were producing, say I would say 1947, TISCO was rolling out around 1 million tons of steel per annum. That was the production. So, couple of million tons, a few million tons around the time of independence, and today where we stand at 55 million tons, and that is the steel production in 2009. And if you look at the figures, it goes like something like, I would quote 32, maybe 38, maybe 44, 55. So, this is the figure at 2009, and these figures are all in million tons. This is the figure in 2006, this is the figure in 2005, and this is the figure in 2003. Steadily. But even if you take, one important thing here is, if you take this 55, these are all in million tons, million metric. We are steadily growing. Now, the projection says that by 2012, this is the Ministry of Steel's projection, we are going to produce around 100 million tons of steel or 110 million tons of steel, and by 2020, we are talking about 180 million tons of steel. So, that is, so these are all projections. These are the real data, and on the right 212 and 2020 are the projections. Now, in 2008, roughly 1308 million tons of steel was produced globally. This is the global steel production, and I have mentioned at one point of time that steel production in the last 50 years has surged from 200 million tons, and now today is 1308, so which is about 6-fold higher. Population is increasing, the society needs steel for development. We have to make bridges, we have to make roads, we have to build houses, infrastructures, and so on, and everywhere we need steel. So, the society is really hungry for steel, and that's why we see this trend also globally, and it's a mere reflection in the country also, that the production of steel is going to increase continuously up to 220 million tons. And here the share of India was roughly about 50 million tons. On the other hand, China was producing about 400 million tons, significantly larger. Today, if you look at the Asian countries, more than 50% or around 50% of the world's steel is produced in the Asia itself by countries like China, Japan, Korea, and India. These are the 4 major steel producers in the Asian countries, and if you sum up all their rated capacities, I mean how much they produce, you will find that it turns out to be almost 45 to 50% of the global steel production. We are going to examine this, in order to achieve these targets, what we have to do, where we stand right now, what are our problems. If you have traveled up to this far, how difficult it is going to be for us to go to 180 million ton. Does it look too rosy, or really we are capable of doing it, and that we are going to examine in this concluding lectures. Now, one important aspect here is if you take 55 billion tons and India's population, if you set it 1.1 billion, right, that is the population of India. So it turns out that 55 kg is the per capita steel consumption. 55 kg of steel per person, and this is per year, which is called the per capita steel consumption of the nation. Although this figure is an average one, there is quite a drastic range of the value, and someone estimated that in the villages of India, per capita steel consumption could be as low as 2 to 5 kg. For example, imagine in my house, I have lot of gadgets, I have a car, the fans are there, electrical equipments are there in my houses, okay, which are made out of steel. So I consume lot of steel. I have a lawnmower that is made out of steel, I have a car that is made out of steel, fans, air conditioners, fridge, everything is made out of steel. Go to a villager, a village hutment, and if you see that steel, perhaps only the utensils are steel, and that's what you see, that the villagers or the villages in India on a per capita basis do not consume much steel also. If you look around the huts, there is no steel in the building in the villages, these are hutments. If you go to the roads, there are no steel used in building, making the roads, they are all kacha roads. If you go to the village and look at the bridges over a little river or riverine, you will see that the bridges are made out of bamboo, okay, or wood. So virtually there is not much steel, but there is quite a bit of scope, okay. We have to, if the standard of life has to go up, the roads has to be laid properly, the bridges have to be built, truck bodies, we cannot afford to make the truck bodies out of wood, anymore. So the truck bodies have to be made out of steel. So that we anticipate that as the prosperity, if you go by that slogan of Gramat Buddha, Dishat Buddha, if the villagers, upliftment of the villagers will necessarily see a surge in the requirement of steel in the country, because as the villagers increase their standard of living, they will demand for more steel. And where from the steel is going to come? The steel is going to be rolled out from the factory, and that's how the country has to produce more and more steel. So the demands are justified. We have 1.1 billion people, we are consuming too little amount of steel, and as I said that, well, this could be 2 to 5 kg in the villages, and while in the cities it could be about, some people maybe, a few people may be consuming 200, 300 kg of steel, and so on. So the world average steel is, if you take the total, divide it 1308 million tons divided by the total population of the world, then you get the global average of per capita steel consumption, which comes out to be 120 kg per person per year. On the other hand, if you go to European nations and Americans, okay, where every house may have one or two or three cars, a lot of steel structures, the house is made out of steel, the kitchens made out of steel, furniture is made out of steel, and there you can see that this value, in advanced countries could go as much as 300 to 350 kg. Even if you think like, if you go up to the global average of 120 kg, you can imagine that 1.1 billion, and maybe by 2020 we will be 1.3 billion. So 180 from that point of view is even less, okay. So if you go up to 1.4 billion person, okay, so in that case we can see that if you go to 180, possibly we can get about 100 kg or 110 kg, something like that, which will be pretty much close to the global average or so on. So this is a reasonable, taking into account, the projection is not unrealistic, the projection is realistic. If the standard of living of the entire nation has to go up, 180 is perhaps the value where we should stick to around 2020 with a net population of about 1.3, 1.4 billion people. Now, how are steel made in this country? Okay, before independence, these are the three sectors. Now, we will examine everything in the perspective of the current domestic steel scenario. So we have basically in the country primary producers, call primary and secondary producers. That's where from our steel comes, secondary producers. Or we can say that, well, we have integrated steel mills from which steel comes. We have mini steel mills also from which steel is produced. So, mini mills are basically secondary producers. Primary producers are basically primary, the integrated steel mills. And in secondary producers, we are talking about not only electric arc furnace, but we are talking about induction furnace steel making as well as electric furnace steel making. These furnaces are very small capacity furnaces, 2 to 5 tons furnaces. On the other hand, electric furnaces in this country, we have about 30 ton size is the maximum, 30, 35 ton size. Primary producers uses BOF vessel, and we have converters in this country which goes up to 320 ton size. Ladles also, I have mentioned to you, ladles and converters, they are of the equivalent capacity. So, ladle and ton dish, they both have about 300, that's Bokaro steel plant has about 320 ton size LD converter. So, both primary and secondary steel producers have been producing steel, and interestingly, this is a unique feature of the Indian steel industry is that till around 2006 or so, the share of the primary producers to secondary producers was roughly about 50-50. That's the kind of production, say 20 million ton through primary producers, 20 million ton through the secondary production. We must understand that this has also been reviewed, that the raw materials are basically different. When we talk of primary producers, we are talking of integrated steel mills, we are talking about blast furnaces which produces molten metal or molten pig iron. On the other hand, when we are talking about secondary producers, secondary steel making, we are talking of induction furnace and EAF. There is no blast furnaces. Okay, so therefore, the charge from which we are going to melt, make steel cannot be solely the scrap, because of the simple fact that our steel consumption is also not too large that the society is going to generate too much of scrap. You go to US, you go to, for example, Europe, you see, there are so much of scrap is generated because people are using car. Every third year they buy a new car. So, the old car becomes scrap. So, but in this country, because we consume less, we do not produce much scrap. So, therefore, what are the basic materials from which the induction furnace and arc furnace produces steel? It is basically the DRI, direct reduced iron. So, that is why, since 50% of the steel or 45% of the steel produced in this country are through secondary routes, okay, through induction furnace, through EAF, and that the induction and the EAF is based on the DRI. So, we must now understand that in the absence of scrap, when you use large tonnage of DRI, the country must be having adequate facilities for the production of DRI. And interestingly for you to note that we are the largest producer of DRI in the whole world. So, we are number 1 here. And what is our rank of steel producers? In 2009, we were the 5th steel producer, along with China at the top, Russia, then we have Japan, then we have Brazil, and then we have India. So, this is the 5th, and we ranked 5th in 2009, which is steadily going to improve. And as far as DRI is concerned, we are the first rank holder. How much of DRI we produced? Around 2006, we produced about 14 million tons of DRI. So, we are not very good in keeping statistics. So, these values, that is why every time I write with an approximate sign, which means it could be 15 million, it could be 13.5 million, and so on. So, this is a reasonable value that I am, authentic value that I am trying to quote here. But 2009, the DRI production was somewhere around 21 million ton, 20 or 21 million ton. Now, we must, and in the foreseeable future also, we would expect that in view of this growth, projected growth, the secondary steel producers are going to stay there and contribute immensely to the production, domestic production of steel. Why I am saying that? Because when you are talking of primary producers, you cannot really produce all the steel from here to here through the primary production routes or the integrated steel mills, because setting up an integrated steel mill requires huge amount of land, and today, as you all know, there is so much of dispute in the country about the acquisition of land. You have to have infrastructure, you have to have huge cranes, huge vehicles or excavators, land excavators, in order to prepare the premises for the steel production. You require enormous amount of cash flow, and you require large bases of vicinity in the location in the vicinity of the raw materials. There are so many constraints. So huge capital cost, infrastructural facilities, land acquisition problems, investors, and all this perhaps will not allow the primary steel sector only be growing and contributing to 180 million ton. We will perhaps anticipate that we can anticipate here that simultaneously also the secondary sector is going to grow, because secondary sector as such does not consume that much resources. You can have electric arc furnace facility and in a very small premises, capital expenditure is small, and so on. But two important issues come here, that when you are talking of secondary producers, the secondary producers all rely on the source of electricity, and most of them, they are not doing that well, so that they can have their own captive plants. Most of these plants, actually secondary producers, they depend on electricity from the local state governments, and that's why the cost of steel production, cost of steel produced through secondary routes tend to be enormously high. So if the secondary steel sectors grow in this country, we must understand that the production of DRI has to further increase, and it is projected that by the time we hit here somewhere, we are talking about 2020 somewhere around 50 million tons. That's the kind of DRI we have to produce, and also the secondary sectors must tighten up their belt in order to sort out the issues, pending issues with electricity generation and so on. I'm going to talk about the problems more in a little bit later. Now, if you look at this statistics and the primary versus the secondary producers, we note that we have basically, because without talking about the raw material a little bit, it is, I cannot really go further and explain certain key issues. We have an excellent resource of iron ore in this country, if we are aware of this particular fact, and I think we have both the kinds of reserves like hematite and magnetite. And I think the hematite reserve goes somewhere like million tons, and approximately magnetite reserve goes like this. And these are extremely high, good quality iron ore, and we are talking about 65%, 60 to 65% iron. That's the level of iron we are talking about. And today, there are a lot of interest on the part of the steel makers to have their captive steel mines. As far as there are certain localities in India, there is one called Chiria mines, somewhere, Chhattisgarh area, and very high, very good quality iron ore, and a lot of interest is there on the part of the steel making companies to take that on lease. But all through India, whether you talk of the Bellary district in southern India, or you talk of the eastern India, which is Bastar district and close to Jamshedpur area, that is Singhbhum district. We have excellent, throughout the eastern India as well as southern India, and to some extent western India also. We have excellent resource material as far as iron ore is concerned. We have some problem though, because we are in this, we have silica. Our ore is high silica. Silica is almost about 2.5%, and we also have alumina, which is about 2.5%. So this is a problem with iron ore. What about coal or coke? The reserve of coke and coal runs in billions of tons. Now, roughly we have, say, coking coal and non-coking coal. And this is about 170 billion tons, and this is about 40 billion tons. And out of this, 30 billion tons and 140 billion tons. This is inferior, and this 30 billion tons possibly is good in terms of making direct reduced iron and so on. The issue really is, these are estimates of reserves. Does that mean that we can take out each and every kg of coal from the mines? No, they depend on the bed depth where they are located. Okay, so the problem with Indian coal, both coking and non-coking, is the high ash, and that's why today you see there are a lot of coal washeries. You have plants which are based on the shore, which functions on the blending of the coal. So we have our coke, which is otherwise fine but contains a lot of ash, and this coal, the coke, is mixed with the imported coke, which has a relatively lower amount of coke ash, and when you blend the two cokes, you get a resultant mixture which has intermediate ash, and which you charge into the blast furnace in order to have good production rate and coke consumption rate in the blast furnace itself. So there is no dearth of material as far as this is concerned. Actually, so much of iron ore we have taken out in the last few years that the country does not have the means to produce steel, and as a result of what happened is we landed up to be a net exporter of iron ore, and these are high value product. I mean, we should have been manufacturing iron and steel in our country rather than importing, exporting the raw material outside. We were, one of the largest exporters of very high grade iron ore during 2007, 8 and 9, but I think the ministry is now, the central government is now putting some kind of an embargo and discourage people. Now, that's why, I mean, the abundance of raw material, high quality raw material. Okay, let me just talk about lime. We also have good quality lime or the fluxing material available in the country, but so far as Indian lime, is concerned, limestone is concerned, they tend to be a little bit hygroscopic. So that's why that is the only demerit. But other than that, as far as the silica is concerned, this is relatively less. The lime has 50-60% of CaO, which is a very good quality, as far as the making of iron and steel is concerned. Now, we have many players which have come to manufacture iron and steel in the country, and after independence, both private and the public sector steel industries have grown remarkably, and today I think roughly 66% of Indian steel produced is through the private sector, and 34% of steel is through public sector. In the public sector steel plants, we have, for example, SAIL plants. There are many such, and RINL. These are Rashtriya Ispat Nigam Limited, that's the Vizag based steel plant, and that's what I said. Vizag steel plant, it is shore based steel plants. So why it is shore based? Because it uses blending of coal. So you import coal, then you blend it. So if your plant is located close to the seashore, then importing and exporting the finished product becomes much more easier. Transportation cost is minimal. SAIL has very many plants, starting with Durgapur steel plant, Durgapur alloy steel plant, then you have Rourkela steel plant, Bhilai steel plant, and now Bhadravati Iron and Steel Company, Salib steel plant. So these are many, Bokaro steel plants. So there are many of these which are managed by the Steel Authority of India Limited, which is headquartered in Delhi. There is private sector steel industry has grown remarkably over the years, and this private sector comprises both the primary producer and the secondary producer. So what are the key primary producers in the country? The key primary producers in the country are the Tata, Jindals, then Mittal. This is not, by the way, Mittal Steel. This is the Ishpat Group, Pramod and Vinod Mittal, who has works near Bombay, a place called Dolvi. So you have SR. And now the projected is POSCO is going to come, and POSCO is projecting 12 million tons plant, 12 million ton per annum plant, and you must be reading many a times in the newspaper, how difficult it is for POSCO to set up, sort out the land issues, the mines issues, and so on and so forth. Jindals have many steel plants. They have steel plants in Bellary district, which is Turangolu. They have steel plants in Raigad, that is in Chhattisgarh. They have steel plants in Hisar, which is a stainless steel company, and various places. Tatas have their works, principal works in Jamshedpur. They are also looking for some expansion in the MP district and all. But today in Jamshedpur, Tata makes more steel than it used to do 10 years back. So there is a huge expansion program going on in Tata itself. So the plant that Jindals have in Turangolu, it's initially started with 2 million tons, then it went up to 4 million tons, and currently it is producing 7 million tons in one single place. And so this is the JSW plant I am talking about, Jindal Southwest in Turangolu near Bellary. So, and this now produces 7 million tons, which is expected to go up to 10 million tons. So in the one single campus itself, they are producing about 10 million tons of, will be producing 10 million tons of steel. JSW is thinking about setting up new projects also. So this is a future project. These are all existing projects, huge capacity plants, 3 million ton, 4 million ton, 7 million ton. These are the rated capacities, several million tons per annum. Mittals are also the future players. This is the LN Mittal group, ArcelorMittal group. Actually, they are also planning to set up plants somewhere in the Jharkhand district. So the Jindals, for example, as I have mentioned, Tatas are planning for expansion elsewhere also beyond Jamshedpur. Similarly, Jindals are also looking for expansion elsewhere. For example, I think 4 or 6 million tons of steel plant has been envisaged by JSW at Shalboni in West Bengal. Similarly, in Angul, JSPL, Jindal Steel and Power Limited, which is Raigad based, Raigad in Chhattisgarh, and this is the Navin Jindal owns this plant. So they are planning for some additional facility, new facility in Odisha, Angul district. So new projects are also coming up, and this new projects, there are altogether new players also. So they are quite old timers as far as steel is concerned. SR is also has expanded their production capacity in Hazira works, and they have also started making steel somewhere in Odisha also they have started their production. Apart from this, many steel plants, these are the old timers like as I have mentioned already. So these are integrated steel producers, Ishpat Industries, Hospet Steel, Sunflag, SR, Jindal, Stainless Steel, JSW, JSPL, Tata, and this is I am talking about the private sector. And because we need more investment, more steel, new players have come, Bhushan Steel, Adhunik Steel, Sham, Balaji and so on. And these are basically, these either have small blast furnaces, mini blast furnaces, or they have huge blast furnaces. And when you talk of mini blast furnaces, you must be knowing that mini blast furnaces is about 50 to 300 meter cube. That's the volume of mini blast furnaces. Hospet Steel, for example, they have a 350 meter cube blast furnace. And you have many secondary producers also, innumerable secondary producers. It's not possible to list all of them. I have listed some key players. So Mukund is one, Moscow, Mahindra Eugene Steel Company is one, Kalyani Carpenter Special Steel, Lloyds, and there are many other steel plants which are based on electric furnace as well as. These are the prominent players, and they produce high quality alloy steels for automobile applications and for key engineering applications. Now, one important aspect about the secondary steel producer production is that why it is that the arc furnace steel making has not really grown in India. I mean, if you look at the number of induction furnace facilities, they are roughly about 700. On the other hand, you have barely 30 to 40 electric arc furnaces in India. So the secondary sector also that produces steel, and in this country, very interestingly, that most of it comes, or a bulk, a major chunk of it comes from the induction furnaces, where the number is really enormous. And it is basically because setting up of an induction facility is extremely inexpensive in comparison to an EAF facility. Now, the electric arc furnace in our countries are also age old. Their sizes are small. What are the characteristics of EAFs in India, for example? It's a small size, very small size. When outside, in advanced countries, you can see about 400-ton size of electric arc furnaces. In our country, the electric arc furnace size is small, barely about 30 metric tons. Our electricity is a major problem. Well, this is a problem with induction furnace also. We have problems with technology. These furnaces are age-old furnaces. For example, if you go to Moscow and if you see their electric arc furnace, a very, very old furnace, actually 30, 40 years old furnace with not much process control, with not many sensors. And finally, when we are talking of, we have low efficiency transformers. The transformers are also not good, which cannot feed in really low efficiency transformers. So the tap to tap time is really high because you require melting, and refining. Today still, if you go electric arc furnace steel making, they are making life of integrated steel makers miserable in terms of providing the right kind of competition, because so many developments have taken place in electric arc furnaces, which you may have done, starting from cojet technology, submerged gas injection, fume hood analysis, good process control, good end carbon determination, and on every front, electric arc furnace has undergone revolution, and as far as steel making is concerned. But when you look at the steel making, EAF steel making facilities in India, you become really sad to note the state of things. And that's why the steel produced by electric arc furnaces is not significant in this country. No new facilities have been erected in recent years because we do have problem nationally. We do have problem as far as electricity is concerned. So nobody wants to invest money in electric arc furnace. So whatever is we are maintaining sort of a status quo, the old EAFs are continuing, the old EAFs are again not that good, and that's why the rate of production is small, very, very low, and that's why people found out that why invest money here? Invest money in induction furnace, and which is very which consumes less amount of small resources, and yet you can make a lot of steel, and that's why you see a proliferation in the induction furnace facilities. So also one important aspect is that when you produce DRIs, you produce DRI fines. And people have found that in induction furnace, those DRI fines, we are talking about 3 millimeter size. These DRI fines cannot be really charged into the EAF, because from the electrodes, when you have when you strike the arc, what happens there is going to be tremendous amount of splashing and fume gas evolution and so on. So if you tend to add the DRI in a continuous mode into the EAF during as you arc, what is going to happen is lot of the DRI is going to be driven out. So the induction furnace, on the other hand, can accommodate these fine DRIs very effectively, and that's why people have found that these fines are relatively cheap in the market. Okay, so we need a melting facility, small scale melting facility, not with much capital investment, which can accommodate the DRI fines, and it is induction furnace which can very elegantly do that, and that's why people have found that making of steel through induction furnace is going to be relatively cheaper rather than setting up a EAF and trying to do the same thing. So we have mini blast furnaces here as well as large scale blast furnaces. We have induction furnace melting facilities. These are, of course, they all have electric arc furnace facilities. There are many such small players who have induction furnace facilities. Now we'll talk about a little bit about the layout of the plant. Now, although these are integrated, let me first talk about the integrated steel making units. That although they are basically they make liquid metal, pig iron, and process pig iron through steel making. All of them uses oxygen steel making. Today nobody talks about Thomas process or Bessemer process. So, but the process route that is followed by these integrated players are drastically different. For example, if you go to Hospedt Steel, you find a mini blast furnace. If you go to Ispat industry, you will find out they do not use traditional oxygen steel making process. We have in Ispat industries, what they have is a process called Konark process. It's a twin shell converter plus arcing. So there are two shells. So it has a feature of electric arc furnace as well as converter, and you know why it is. You have done steel making, so Konark process gives you the flexibility to have desulfurization and dephosphorylation, okay, under different conditions, and which can be, one is a converter when you blow in oxygen, and another is the arcing process where you can maintain a reducing atmosphere, and then you can possibly do the desulfurization as well. SR Steel has a huge electric arc furnace also. JSW, for example, they have Corex. You may have done in iron making. That Corex process, the largest Corex furnace is in the JSW, which is producing more than 1 million tons of steel per annum. This is a direct smelting reduction process. If you know, this is the only plant in India which has facilities. So Ispat has a Konark process. Corex does not. JSW has both blast furnaces as well as Corex. We also know that Corex process produces high calorific gas value, okay, which can be converted into power also. So if you go to SR Steel, you find they have a huge electric furnace facility. By the way, SR has the biggest DRI is 3.6 million tons per annum. That is the rated capacity of the DRI facility with the SR group. So they make briquettes and they produce, they charge it into the furnace, electric arc furnace. They have a little bit bigger size electric arc furnace, I think more than 100-ton size, and there they produce the steel. So it's not the same. Tata Steel, conventional LD process, big blast furnaces, 6 or 7 in number, and they have secondary steel making. They have both slab casting as well as billet casting facilities. So that means they produce long products as well as flat products. If you go to JSPL, they have both electric arc furnace as well as liquid metal production units like blast furnaces. They have also bloom casting, near net ship casting as well as slab casting facilities. So they produce both flat products as well as long products. JSW at Turangolu is a flat product plant. They don't have billet or bloom casting. They produce slabs. There again the hot metal is produced through Corex as well as blast furnace, and then we have steel making, which is done through LD steel making. Jindal Stainless is an old, it's not an actually integrated steel plant, so I should have got it here. This is an alloy steel plant. They make stainless steel, and they have electric arc furnace where stainless steel is going to be is produced. They also have slab casting facilities, continuous slab casting facilities. All these plants have actually SR Steel. I have already mentioned, electric arc furnace based, slab casters, flat product mill. Ispat also, Ispat has, for example, is the only plant which has thin slab casting, and I think Bhushan or Adhunik also in their east coast, the Odisha plant also have the thin slab casting. I think Adhunik group have thin slab casting facility in their Rourkela works. So Konark process, Ispat has Konark process, so they have a big DRI production facility also in Dolvi, and this DRI is used in the converter Konark process. A part of it, they have also blast furnaces there, and they use a lot of secondary steel making, tank degassing. They have converter size, for example, we are talking about 185 tons, you are talking about 130 tons, you are talking about 100 tons, you are talking about I think 120 tons and so on. If you go to Bokaro steel plant, for example, 320 ton. If you go to Rourkela, the converter sizes are 100 ton. So each plant actually is different. There is no comparison between one plant with the other in terms of their capacity, in terms of their steel making circuitry, in terms of their product, in terms of their efficiency, in terms of their environmental friendliness. I think all these are different from one plant to another plant. So far as the secondary producers are concerned, they are basically electric arc furnace based companies. Whatever I have listed there, I have not listed those which uses induction furnace. So I would say that most of them uses electric arc furnace coupled with a lot of secondary steel making and continuous casting. And KCCL, for example, they produce continuously cast slabs. On the other hand, if you go JSSL, this produces stainless steel slabs, and Mukund Steel, for example, they produces blooms and billets. So again, you see most of the small scale plants are actually long product plants, okay, but one or two of them, like KCCL, KCSSL and JSSL, Jindal Stainless Steel, these are the flat products, and most of them are based on electric arc furnace. That means most of them buy DRI from outside, okay. For example, Masco gets their entire feed of DRI from Ispat. Ispat is located in Dolvi, Masco is located in Khopoli. They are close by in the vicinity of the Raigad district, just on the outskirts of Bombay. Similarly, if you go to, for example, Hospet Steel, Hospet also has, buys some DRI from some sources. These plants also buy scraps from the market, and they have huge scrap storage facility, because it is the scrap mixed with the DRIs, that constitute the principal iron bearing feed to the furnace.